Okay, this is now this is our structure that's been imported from AutoCAD. All right, AutoCAD DSL5. So you can see the scale, the drawing, the design is too bigger than the workspace. So I go to view. You can see view here. You click on view, then you use the scale so that you can see the full structure. All right, the full structure is uh, this is the full structure. So this is the ground floor. All right, so what I will do first before I copy multiple floor is the panel edge condition. All right, this is panel 1. All right, I have to change the edge condition. So the edge condition, if you want to change the edge condition here, you first of all click on the panel you want to change the geometry. All right, you click on this panel, then you move to your right side. You can see them here. You move it up, you see geometry. You go to depth of panel is 150. That is the property. Height is when we're talking about height now, we're talking about the y-axis. Then panel interior panel. So this is the edge condition we're talking about. Panel edge condition. You can see this particular panel is two adjacent edges is continuous. You can see two adjacent edges is continuous. You click on it. Okay, now you come again to the next panel. You can move like this, or let's move under. Now from this panel you must go to the geometry to see the property. All right, to know if it is one long edge discontinuous or short edge discontinuous. So you can see the height is 4112. All right, then the width is 4425. It means that the width is longer than the height. All right, so this means that one short adjacent edges, sorry, one short edge discontinuous. You can look at it, one short edge discontinuous. So you click on one short edge discontinuous. That's edge condition of that panel. Then you go to the next panel, panel 4. Also move up here, go to panel geometry. Then that's two adjacent edges discontinuous. You click on it, two adjacent edges discontinuous. Then we'll move to this bigger one. All right, now the size of that panel is 7025 by 3825. So the edge condition is one short edge discontinuous. Then this one as well, the one here, the edge condition is two adjacent edges discontinuous. Then this one is two adjacent edges discontinuous. What do we mean by two adjacent edges discontinuous? You see the right angle edges, the discontinuous. That's the length and the breadth at right angle discontinuous. All right, so that is two adjacent edges discontinuous. So two adjacent edges discontinuous, sorry, go up, two adjacent edges discontinuous. All right, then this one is one short edge. The small panel here is one short edge discontinuous. Move one short edge discontinuous, one short edge. So we are done with the edge condition here now. So what is remaining is to copy this floor, assuming we are doing 3-story buildings. All right, 2 suspended floors. So I want to copy, go to modeling, here, click modeling here, modeling. All right, you copy this floor, all right, you come to copy floor, copy create floor. You click on this because I still want to edit this floor. Remember that this is the ground floor now. There is a staircase hall. So the staircase hall cannot be indicated in the ground floor. That's the damp proof course is there, so that staircase can never be void in the damp proof area. This is damp proof course. So I will copy this, I will copy it. Automatically it has been copied. You go to view as usual to reduce the scale. All right, okay, you can see now this is floor 1. You can see it, you can see it here, floor 2. All right, down corner of your left hand side, down corner of your left hand side, that's floor 2. Okay, oh, this is floor 2. I can now click on this panel. You can see it's panel 6. All right, click on this panel, then go to geometry property, change this one. You can see geometry panel type. Change this panel type to staircase void. All right, it has been changed to staircase void. You can see here. Now this automatically now changes this panel edge condition, all right. So panel 7 edge condition right now is 3 edges discontinuous, 1 2 3 edges discontinuous, 1 long edge continuous. So you go to geometry, you do that there, you go to geometry, go to edge condition, you change it, 3 edges discontinuous, 1 long edge continuous. You click on that. Okay, now you change this edge condition as well. You go up, change the edge condition, 2 adjacent edges discontinuous. All right, because this now becomes the stair hall. All right, this is now a void in the first floor level. So from here I can now copy multiple floors. You go to modeling. You know, when you are designing, it's modeling. When you are doing anything, you are doing is modeling. You can see the 2 bars here, the modeling. All right, you start drawing. Then if you want to reduce the scale, you go to view. All right, from the view you can change the scale to your desired scale. Okay, now I want to copy multiple floors. Now copy multiple floors. How many floors do I want to go? You have ground floor, you have first floor, then you need to go 2 more. All right, because we said it's 2 suspended floors. So R2, then you can see there's depth of roof beam to be 300. Okay, you can also adjust if you wish to, but I want to leave it at like this. Breadth of roof beam, this roof GK. All right, you know roof GK is 1.5. Roof QK, the life load of because of dust, snow in the morning, it's 0.75. Or if you are in the in a place, in a country where snow disturbs a lot, there is a life load on that. You can get that in the BS code. All right, so let's continue. Copy and create multiple floors. So I'll copy and create multiple floors right now. You can see we have 2 suspended floors, then the last floor becomes the roof level. Okay, we have ground floor, that's floor 1, floor 2 is the first floor, floor 3 is the second floor, then the 4th floor is the roof level, which we are going to change later. So apply changes, then close. So when you go, you can see it has been copied already. So I'll go to view to reduce the scale, 125. Then you go to the next floor. You can see they call this one first floor. Go to the down corner by your left. You can see the floor, the down corner by your left, far down corner by your left hand side. You see first floor, Then when you click again, you see second floor. Okay, you see second floor. Then I have to reduce this scale as well, 125. Then you go to the last one, which is the roof level. They call it roof level. All right, look at your far bottom corner of your left hand side. By your left hand side, sorry, you will see roof level. Okay, now I want to go to model again to now change this floor level. Or sorry, let me first of all reduce the scale. Then I can now click on modeling, then go to floor property, the top corner by your right hand side. All right, so you click on it, change current floor panel to roof panel. You click on it. So yes, apply changes. So if you click on this now, it will show roof panel. You know, this shows that there's no panel here anymore. So it's beams that you will see. Okay, so that's it. From here, I will create new beams. Create new beams because all the floor arrangement has been set. So create new beams. You can see that the beams have been created already. All right, but in this case, from this area, I do not want column to be here. I only want column to be from this point to this point because the span is 4112.5. Okay, so I will delete this beam here. All right, follow it and stretch. Then it's either you stretch this one or you stretch the one before the one you are deleting. But in this case, this beam, I want it to get to this point. Okay, so I will delete this one by stretching the one before. Look at stretch span before. So I'll click OK. It will automatically stretch it. You can see that the beam runs from this beam to this beam. So in this case, I can now recreate beams. All right, recreate beam for it to take effect. Now we click from your bottom corner by your left hand side. Bottom corner, you click. You can see this is the second floor. All right, you create beam, create new beams stroke spans. All right, so which I've just done here. So okay, then I will also delete this. I will also delete that span there because I don't need column to be there. Yes. Okay, you can see. And after deleting, you must recreate beams. Okay, you click create beams. All right, now I'm done here now. Then I will click the next, that's the first floor again. Then create new beams. Note that when you want to create beam, create new beams you will click on so that you create new beams. Then when you now modify to what you want the structural beams to look like, after modification you will now go to recreate beams. All right, now I have done this. Now I've stretched this beam from this column to this column. So I will recreate beams, right, to take effect. So of course you know that the last floor is the ground floor. All right, so it means that all the columns are now in place. All the beams are in place. But for me to be sure if my panel is well, if the general floor arrangement there's no error, I'll click on the check modeling. You can see it here, check modeling. All right, you can see it, check modeling. Click on check modeling, check. So there's no error report here, it's plain. I report it. Then check beam modeling. So there's no error report here, everything is in order. Then I'll also check my panel modeling. So there's no panel overlapping each other, so I can now go. So everything is set from here. All right, everything is set from here. Everything is set from here. Okay. Okay, I can proceed. All right. So after doing all of this, the next stage is to design automatically. All right. I have to design automatically. Note that we are using hard foundation in this structure. So I'll go to design. You can see it up here. Right, you can see design. So I will click, I will come to this side, design automatically. All right, so the question, this operation will automatically load, analyze, design, detail, title, block, drawing, and prepare calculation sheet. This might take some time to complete. We have put together the entire process in a unique workflow. Would you like to do this now? Yes. Click yes. All right, so everything is already there. Come to the top corner right side, you click on start automatic design. All right, you go check modeling for errors. You allow the software to check modeling for errors. So you can see it has checked already. Good, no common errors found in the modeling, which I did manually before. So you click OK. Before you continue, would you like the software to delete previously generated results, calculations, detailed drawings, etc? Yes. All right, then loading structure, automatical loading, yes. Analyzing structure, yes. Then analyzing slab, yes. Analyzing beam, yes. All right, then analyzing columns, yes. Designing structure, yes. Designing slab, yes. Everything is yes. Yes. All right. Yes, I want to set floor panel reinforcement certification limits. All right. Now, if you want, well, my spacing for slab reinforcement, normally use 150 center to center. Okay, but it's your design also determines the. Let me leave it at 125 because your design will determine the spacing of your reinforcement. So everything is still in order. Okay, so your minimum bar diameter is 12. All right, your maximum bar diameter 12. Okay, this is a slab reinforcement specification limit. Apply changes. Okay, we'll continue now. After clicking on that, you see set floor beam reinforcement certification limit. Then you now set the floor beams. For me, I don't allow 12 mm to be in my beam design. All right, let me use 10 mm in my stirrups. Then a minimum span top bar reinforcement, I want to use 16 as well, though they are hanger bars. All right, minimum top bar diameter 16. Where we are having top reinforcement, we will have support hugging moment. All right, hugging moment, that is where we need top reinforcements. Actually, we use 16 mm, but for small moment, it's supposed to be hanging hanger bars, but I still use 16 mm. Okay, so we continue. Then a column sizing, do not size column specification below. If you don't want the column to be resized by the software, you can click on this point and don't size column, leave columns dimension the way they are. You can click on that, but it's recommended that you allow the software do its own design. This is automatic. Yes, I'll continue. Now column width, this maximum column width 600, maximum column width 450. Maximum column height, let me see, is 450. Then okay, minimum bar diameter, I'm using 60 mm. Okay, you can see the whole setting. You set it the way you want it to be. You click OK. Now you can see the different type of columns that are here. Different type of columns, they are here. You click OK to continue. You can click on column 1. This is column 1, for instance, to check the property. You see, what did it provide? This one is 4y16. You can see it here, 4y16, and you go for the check session check OK. So it means that the reinforcement is okay for the design. So I can continue. Create foundations, yes. Now assuming you have selected part foundation, you know, before this popped up, suppose if you were not using part foundation, you would have clicked no, so that you will now select the type you want to select. Okay, now let's proceed. You have selected part foundation. Would you like to continue? Yes. Creating part foundation, yes. Ground floor beam is not yet created. Software, yes. Let it do that. So sizing part foundation, okay. Now minimum base thickness, okay, 250. Let's say, yeah, 250 is okay. 250 is okay. Then minimal base length for both height and this, I'll put 1200, 1.2. The length interval, okay, let that one be our limit. Okay, let's go. Staircase design, yes. Then you now impute your number of staircase. This one, in this case, this one is 12. Height of riser, correct. Width of tread, correct. Width of stair, correct. Then width of stair, this is width, this one is width. Width is, you know, is 3 meters. Let's go to AutoCAD. What is our width? This width is 3 meters. Okay, 3 meters. So divide by 2. That gives us 1500. Okay, and then the post load staircase for commercial purpose is 7 kilonewton per meter square. All right, finishes is 1.2. all right, so bar diameter 12. Main bar spacing is not 75, it's 150. all right. Distribution bar 12. Distribution bar spacing 150. Then I can use whichever one. Let me put 16. So you will design. Detailing foundation layout. All right, click OK. Detailing part foundation details, yes. You can see it's already detailing. Detailing columns, yes, it's already showing. Then detailing floor general arrangement, yes, it's already doing that. So at the end of the day, we'll show everyone the details. Detailing floor general arrangement, yes. Detailing roof beam arrangement, yes. Detailing roof beams, yes. Then creating bar bedding schedule, which is very important for quantification, yes, for evaluation. Then if you are in an organization where they need structural calculations, you can decide to print calculation sheets. Then you show the number of panels you want to give a full calculations. Let's say 5 beam 5. Then what's it called now? Every other one that you wish to, you know, prepare the calculation sheet. Yeah, there is that export all design calculation sheet to PDF. Yes. So I can save it. What do I use to save this now? I can save it like calculation, calc. Save it calc. My desktop, save. So at the end of the day, you see it's loading. Alright, it's loading, which means it's saving the calculation in your desktop. So you don't need to cancel, you don't need to cut, you wait for it to finish loading. Alright, you can see you wait for it to finish loading. Alright, so after loading, the AutoCAD the quick civil will pop up. So that has finished loading. So you can see exporting all design calculation sheet to AutoCAD, all design calculation sheet to AutoCAD. No, I don't want that in AutoCAD. Then click yes. You want to prepare detailed drawing to this okay. If you want to prepare title block, if you don't want to prepare title block, but for me, I leave it like this. For now, let us put it in A4, okay, because we are not printing actually, it's in landscape. So we'll click OK. So exporting all design drawing sheet to PDF, yes. Save. Drawing, then you see drawing, design drawing, design drawing. Alright, save in desktop, save, it will still load. Alright, you wait for it to load. Okay, exporting your design calculation sheet to AutoCAD DSF. You can click yes. Creating a formatted this thing. This is this DSF file. You can click yes to save. Let's call this one HHH triple H. Then creative format AutoCAD. Okay, let's call this one GGG. Save. All right, this is the foundation layout. Let me go to the PDF. What did I call the PDF? Okay, let's design drawing. Let's open the PDF right now, so you can see they will prepare your title block for you. All right, they will prepare your title block for you, so you can see. Let me increase. You can see the general floor, the foundation layout. Now this is, they will import it to AutoCAD. This is what you will do. You will edit these lines that are not, you edit the foundation layout, right, to be very neat. You can see that this line is not going through. All right, so you can see that the foundation layout is already prepared. Now let's go to the AutoCAD file. Let me open the AutoCAD file. Let me see. Now look at the AutoCAD file. You now edit all of this. Let me see the other one. Okay, now this is the beta file. Let me delete the first one. Okay, this is the let me delete HHH now. Cancel. I cannot delete HHH. Now this is the beta file. You can see here I've exported to AutoCAD. I've exported to AutoCAD, so I cannot delete all title block. I don't need the title block. I don't need the title block. So as you can see, I don't need the title block. I want to prepare my own title block. Okay, if I want to edit this structure now, I only just need little things to do. All right, just edit this one. I'm done here. Now you can see the foundation, column based details. You can see the column based details. All right, so you just do small editing. See the column details. All right, column details. Now let me go to the PDF file. Let me go to the PDF file. This is the PDF file. All right, so from here you see column basis. All right, it's well executed. All right, but if you want to leave it in your PDF, you must have to, in that your title block, you must you must title your block very well. All right, but for me, I don't use PDF. I export to AutoCAD, then do whatever I want to do. All right, now that's base details. All the bases are here. All right, all the bases are here. Then you can see your column details. Let me increase the font. So you can see column, this is column 1. Column 1, 5 numbers. It's telling you this, we have this 5, this type of column, there are 5 in numbers, okay? You can see the detail. 4Y16, 4Y16, and 4Y16. Then the next one, which is column 2, column 2 will have 4Y20, 4Y16, and 4Y16. So we have column 3. How many do they have there? Column 3, one type, 6Y16, 6Y25, sorry, 6Y25, 4Y20. Now let us go to this column 3 to know why it's like that. Let me reduce column 3. Let's know why it's like that. Column type 3, column, this is column 3, okay? Because of the load it's subjected to now, you can see that it's carrying half of this load, carrying from here, and this is biaxially loaded column. So you can see why it is why. So the structure does a whole lot. All right, you only need little things to do to have to in the structure. All right, this is general floor arrangement. This is general floor arrangement. Okay, this is general floor arrangement. So these are the beam details. You can see these are the beam details, well detailed. So for me, where the lines are meeting each other, that's the only point I did. I move, like for instance, this line now, I move it to this side. It's lesser job to do. So a job that's supposed to take you 2 weeks, you end up doing it 2 to 3 days. So I think that's a plus. All right. So this is how it's done. You can see the slab details. All right. Slab details. Now recall that I taught everyone how to detail manually. Now let me compare this software detail with the one I did online. I taught this one online. It wasn't let me show you what I did. You can see my AutoCAD slab details using my manual calculations, the output from the manual calculations. All right, this was my own details. All right, look at the one the software did. Look at the one the software did. All right, there's no difference. There's no difference. There's no difference. Look at mine. This is mine. If you check very well, this is my details. All right, my details after calculating manually. So if you want to know how I got these outputs from the output I use in Italy, this structure, you go to my previous classes to know how it was calculated manually. All right, the videos are out there, So this is the sorry this is the one done by the software, which is very neat. Right, now let's progress. This is the general floor arrangement for the second floor. Second floor beam details, everything is there. Okay, so this is second floor slab details. Now if we have first floor and second floor to be the same slab, everything the same, so you don't need to redesign or redetail second floor. What you have to just do is say same reinforcement as first floor. Okay, the same reinforcement. Now the roof details. All right, this is just the roof details, everything is well. Now let's go to the this is the bar bending schedule right now. I don't know if most engineers understand what we mean by bar bending schedule. The bar bending schedule will help the quantities of beer to actually quantify the structure. The bar bending schedule is how you place your reinforcement in the structure, in your detailing, how it was bent, you know, the starter bars, right? You just place them the way they are, right? Like this L shape now. If it's U shape you use in your detailing, you must make it U and state the number of reinforcements that you made like that, so that the quantities of your can quantify. Now you can see that the tonnage of steel is also provided by this software. Alright, the tonnage of steel is also provided by this software. Now you can see bar shape. Now the U shape, if you have U shape, you have L shape, the tonnage, they are all there. So at the end of the day, you calculate the tonnage of steel used. You can see tonnage of steel, total length of 8 mm diameter bar is here. Total tonnage of 8 diameter is here. Total length of 12 mm diameter is here. Total tonnage of 12 mm diameter is here. Total length of 60 mm diameter is this. The whole thing is summarized at every section. Alright, probably this one that is summarized is for the roof beam. Then for the roof details, beam details, maybe column, slab, as the case may be. So if you want to do the whole of this bar, this software will do everything for you. All right, so for now, this is where we have to draw the curtain. All right, bar bending schedule. This is a slab reinforcement. Now the bar bending schedule for slab. Okay, no, wait. Could it be slab or I don't think this one is slab. Okay, you see it. Remember description: first floor beam details. Details. All right. The bar mark. The bar mark is also very important in your detailing, so that whenever the quantities of oil is quantified, it goes straight to the bar mark. You see 3Y1601. Alright, how many? Number of member is 1. Number of bar in each is 3. Total number of bars, this length of each 4.7. Then total length, 4.7 times 3 will give you this. Alright, so then this is the bar. Right, this is the bar. So now the length of the bar is 4600. The bent up bar, you can see the bent up here is 100. That is why it's 47. Okay, that's that. So the system explains everything. Now there's another one, the calculation sheet as well. Now let me go to the calculation sheet. The calculation sheet is a calculation. Now you can see the calculation sheet. Now this at the design, or this is the design information. You can see the post load is 4 kilonewton per meter square. Finishes, soil bearing capacity, you know. Now if you have been following my class, go to my class, you see that my UDL, ultimate design load, was 14.52, and exactly what they got here. So 14.52. all right, so that is it for everything. Your calculation sheet, they're out there. So for now, let us call it a day. If you have any question to ask, you can ask. Then if you feel that this one was done before, you can bring a software, or sorry, you can bring a design so that we do it together. All right, so if you are having difficulties designing a particular structure, you can bring it up, we will do it together, and we'll be able to solve we'll be able to resolve everything that is difficult for you. All right, so thank you very much, and God bless.